Hi, welcome to my video lesson now. Here's what we're going to do. We're going to work a little backwards. So given solutions to a polynomial, we're going to work to find the equation to the polynomial. So here's one. Here's a polynomial that has solutions. We'll call them roots. So let's say 3, 5, and x minus 3. And you kind of pretty quickly know that's got to be x minus 3 for this one, x minus 5 for that one, and x plus 3 for that one. But since we're talking about solutions, we kind of mean a polynomial equation. Okay, so there's our answer. And we could slap in other roots that could have other solutions, but that's our simplest answer. And we don't need to multiply this out. We can leave it that way. If we needed to, we could. Okay, so here's a new theorem. It's new. The irrational root theorem. And you should kind of have a sense of this, that if we have a solution that has a 0, a plus b root c, that it also has its conjugate as a solution, a minus b root c. So for example, if x equals 3 minus 2 root 5 is the solution, then we know that x equals 3 plus 2 root 5 is a solution. And this shouldn't surprise you. It should look like the quadratic formula is at work here. Okay? So here's what we can do. Give an equation that has to a polynomial that has solutions, these three. So from the first one, we know that one factor has got to be x plus 4. And from the second real one, or I should say rational one, we know that this solution has to have a factor of x minus 2. And because of our theorem that we just saw, we know that not only does this have to be a solution, but also x equals 1 minus root 5 has to be a solution. So that means that one solution is x minus 1 plus root 5. That's for this one. And another one is x minus 1 minus root 5. And that's for this one. And our equation, since it's an equation, we'll make it equal to 0. Now that's ugly. So we need to clean that up. So here's the little algebra that I'm going to do. X plus 4, x minus 2. And now I've got to distribute this monkey all over each other. So here's x minus 1 minus root 5, x minus 1 plus root 5. I've distributed the negative sign. And now I've just got to do some multiplying out. So let's see what we've got. So I'm going to do x times x, it's x squared. X times negative 1 is minus x. X times root 5 is x root 5, so plus x root 5. Then I'm going to have a minus 1 times negative x minus x. Then a minus 1 times a minus 1 plus 1. Then I'm going to have a minus 1 times a root 5, so minus root 5. Then I have minus root 5 times x here is minus root 5x. I'm going to write x root 5. And then minus root 5 times minus 1 is a plus root 5. And then a minus root 5 times a positive root 5 gives me just a minus 5 equals 0. That was fun, some good math. Now notice, by this pattern here, we have some things that can cancel. I have a plus x root 5 and a minus x root 5. I have a plus root 5 and minus root 5. And notice what's left is all rational. So I have x plus 4 times x minus 2 times x squared minus x is minus 2x. And then plus 1 minus 5 is minus 4 equals 0. And that's my best answer. Okay, I could continue to multiply this out. You can kind of see how I'd be working backwards. I'd get to this point, and I'd have to use the quadratic formula, and that would give me these two answers. Okay? Okay, so here's one for you to do. And so I'm going to pause. You should pause this, give it a try, and then watch the worked out solution. So it's going to show up in a minute. So pause it now. Let me pause, and the solution will magically appear. Okay, so there's my solution. Sorry, it's blocked. Okay, and what were key things? 3 root 2 times negative 3 root 2 is 9 times the square root of 2 squared, so it's negative 18. And one thing I can do, just to be sure, is I can check my answer on this part, and I can use the quadratic formula to solve for when that's 0. So that's negative 8 plus or minus the square root of b squared, which is 64, minus 4ac, which is going to give me a 4 times 2 times 1, but it's a negative 2, so it's plus 8 all over 2a, which is 2, which gives me a negative 8 plus or minus root 72 over 2, but root 72 is 36 times 2, so that can be negative 8 plus or minus 6 root 2 over 2, and then if I cancel the 2 out, I get a negative 4 plus or minus 3 root 2, which is what I wanted up here. Okay, so those two solutions. So there you go. Okay, so here's our next old theorem. This is brand old. That's the opposite of brand new. But you knew this one already. If the imaginary number a plus bi is a root, then a minus bi is a root. So here's a polynomial with these two roots. Now I know that it can't have just those two roots. It's got to have a third root, which is the conjugate of this one. So x equals 2 minus I. And to find that polynomial, I've got to do the same thing, but I got to be good with multiplication of imaginary numbers. So I know that now I said polynomial with roots here, so this time it's not a solution. I can write y equals x minus 3, and then x minus 2 plus I, and x minus 2 minus I. And then I go through the same routine I went through before. So I'm going to keep the x minus 3 by itself. That one's good. I'm going to distribute that negative sign. So x minus 2 minus I, x minus 2 plus I. And now I've got to go through my multiplying out. And what I'm going to end up with is, you might guess, a quadratic with no real roots. So x times x squared, x times negative 2, negative 2x, x times I, ix, negative 2 times x minus 2x, negative 2 times negative 2 plus 4, negative 2 times I minus 2I, negative I times x minus ix, negative I times negative 2 plus 2I, negative I times I, remember I squared is negative 1, so this gives me a plus 1. So it's because it's a minus a negative 1. So plus 1. And now if we look through this, the ones with ix, positive ix, minus 2i plus 2i, those cancel. And I'm left with only real valued coefficients. So I have x squared minus 2x is minus 4x. And then plus 4 plus 1 plus 5. And there's my polynomial. And if you check this with the quadratic formula, you'll find that the solutions for this are those two values. Okay, so here's one more problem. Find a polynomial with these two roots. So you can pause the video now and I'll solve it, and then you can check your answer. Okay, and there's your solution. So once I see these two, I know that it has to have a third one. So it has to be at least third degree, and there's my answer. So thank you for listening, and I hope this all made sense.